Welcome back. In this set of videos, we're going to be looking at multiplying and dividing rational expressions. A rational expression is a ratio of two polynomial expressions, or in other words, it is a fraction that includes polynomial expressions in both the numerator and denominator. So here I have a couple different examples of a rational expression. When we're looking at rational expressions, the first thing we want to be able to do is just simplify. And to simplify a rational expression, I'm going to go back to how we simplified fractions. We should be familiar with simplifying fractions. The method we're going to use here is canceling out common or like factors from the numerator and the denominator. So I'm going to write the numerator as 4 times 2. So I'm going to write this numerator as 4 times 2 because that's 8. And another way of writing 12 is 4 times 3. Those 4's in the numerator and denominator cancel out, so this is 2/3. So when I'm simplifying a fraction, I just cancel out like terms. When I'm looking at simplifying something like this here, the first thing I want to consider is that I need to get like terms. I was able to factor 8 and 12 because I know my factors. I'm going to need to do the same thing here. So your first step when simplifying is to factor the numerator and the denominator. So x squared plus 4x plus 3 is going to factor to be x plus 3 times x plus 1. And the denominator, x minus 6 doesn't factor, but x squared minus 9 will factor to be x plus 3, x minus 3. Before I go ahead and simplify, so before I go ahead and finish this problem, I need to think about domain restrictions. We have a really important piece of math that says that I cannot divide a number by 0. Division by 0 is an illegal operation. So my domain restrictions are going to be any values that make my denominator equal to 0. So when I look at this, I need to do my domain restrictions before I simplify. So here I'm going to say x cannot be equal to 6, x cannot be equal to -3, and x cannot be equal to +3, because if I plug 6 in, my denominator is 0. If I plug -3 in, my denominator is 0. And if I plug 3 in, my denominator is also 0. So when I'm simplifying this, now that I have my domain restriction, I can cancel out like terms, which is x plus 3 is a like factor. And I'm left with 5x times x plus 1 over x minus 6 times x minus 3. So factoring this here is going to allow me now to have a simplified expression, but I have to keep these domain restrictions in mind. On this theme of domain restrictions, I want to look at two different sets of examples where I have some domain restriction issues. So when you are looking at domain restrictions, we are asking the question, what values will make the denominator equal to 0? What values will make an illegal operation? So in this first example, I'm going to look at all of the factors in my denominator, and I'm going to say 12 cannot be equal to 0, and I have no problems with that. 12 is never equal to 0. My next term is x. X cannot be equal to 0. So this is one of my domain restrictions. My next term is y to the 8th. Y to the 8th cannot be equal to 0. So y cannot be equal to 0. And my last is z squared cannot be equal to 0. So z cannot be equal to 0. So this has 3 domain restrictions. X, y, and z cannot be equal to 0. When I look at my domain restrictions for this other problem, I'm looking for values that will make the denominator equal to 0. The easiest way to do this is to factor the denominator and set each factor so that it can't be equal to 0. I'm also going to factor the numerator because when I'm simplifying, I want to have a fully factored numerator and denominator. I'm not going to simplify this, but it's a good first step to get in the habit of. So this numerator will factor to be x minus 3 times x minus 1, and the denominator will factor to be x minus 5 times x minus 1. Just like I did over here, I'm going to take each factor, x minus 5 cannot be equal to 0, and I'm going to solve that, and I'm going to get x cannot be equal to 5. That is one of my domain restrictions. Then I'm going to take x minus 1 and say that that cannot be equal to 0, so x cannot be equal to 1. These are the domain restrictions for the problem, and they hold even after I've simplified. So in this example where I simplified, the domain restrictions hold even for my simplified equation. Because this equation is a simplified version of this, but when I check values to see if I make a true statement or if I have the same quantity or the value is the same, I have to go back to the original expression. Let's look at one more simplifying example. In this case, I have multiple variables being added and subtracted, so I'm not going to consider domain restrictions here. If you've got variables interacting with each other, in this particular class in Algebra 2, we're not going to look at the domain restrictions for that, but it is something that will come up potentially later on. So I have this example here. I first want to start by factoring. So when I simplify, step 1 is factor. So in the numerator, I see this term has a common w, so I can pull out a factor of w, and I get 4w minus 3y times w plus y divided by 3y minus 4w times 5w plus y. Right now, I don't see anything that can cancel out, but I do see something interesting. I do see that these two terms here are very similar. 4w minus 3y, 3y minus 4w. I have the same two terms. I have a 4w and a 4w, a 3y and a 3y, but they have the opposite signs. Whenever you see something like this, so an a minus b over b minus a, if instead of pulling a w out, I had pulled out a negative w, this would have been negative 4w plus 3y times w plus y divided by 3y minus 4w times 5w plus y. If I rewrite this, if I look at this problem here and I switch my w's and y's, this becomes 3y minus 4w. 3y minus 4w is exactly the same thing that I have down there. So this is really negative w times 3y minus 4w times w plus y divided by 3y minus 4w times 5w plus y. 3y minus 4w in the numerator and denominator will cancel, and I am left with negative w times w plus y divided by 5w plus y. This is a common thing that you're going to want to keep in mind and keep track of. If you have things that look almost the same, but with opposite signs, try factoring out a negative one.